In my program, I want to demonstrate the concept of variance with generic type parameters. So let's create a method called dump people. And I'll explain why this is dump people and not dump employees in just a minute. But I'll give dump people an employee repository. And let's create that method and fill out an implementation that will do this. I'll say, give me all the employees. And let's just loop through those employees. So for each employee in that employees collection, we will just write out the employee name. Now, suppose I want to reuse the logic inside of this method. I want to use it not just for employees, but imagine my person class is also an entity, and I want to use this method both with an iRepository of employee and also an iRepository of person, which seems to make sense. After all, every employee is a person. It derives from the person class. So in the spirit of object-oriented programming, this seems like something I should be able to do, except I'm getting a compiler error. The C# compiler is saying that it cannot convert iRepository of employee to iRepository of person, which seems odd from an object-oriented programming point of view. Let me try a different experiment here. Let's say I wanted to treat all employees as an IEnumerable of employee. And that works fine. It's again in the spirit of object-oriented programming because the repository returns iQueryable of T, in this case iQueryable of employee, and iQueryable inherits the IEnumerable interface. So that line of code works, and anyone who does object-oriented programming would expect to be able to reference a derived type using a variable typed as a supertype. But what is surprising about this IEnumerable experiment is that I can change this to work with IEnumerable of person. That line of code the C# compiler doesn't seem to mind. It's perfectly legal. So why can't I do this with my iRepository interface? Well, we'll see the syntactical answer if I go to IEnumerable, put the cursor there, press F12 to go to the metadata view. And in this view, notice the out keyword. Out is known as a generic modifier, and it means that IEnumerable is covariant. Before I can explain covariance, let's go back and look at iRepository of T. It has no generic modifier. This is what we call an invariant generic type parameter. As the name implies, there is no variance, there's no wiggle room. The generic type used as an argument is the type we have to use. There is no ability to treat an iRepository of employee as an iRepository of person. Doing that requires covariance and this out modifier. Covariance then allows for some wiggle room. The methods inside the interface are allowed to return a type that is more derived than the type specified by the generic type parameter. More derived. In other words, a covariant interface like IEnumerable would allow getEnumerator to return IEnumerator of employee even when T is type person. Employee is more derived than person. And that makes a lot of sense from an object-oriented point of view. If something is always giving me back employee objects, why can't I just treat those objects as person objects since every employee is a person? It's just that in C#, that does require the out modifier to explicitly make the interface covariant. And covariance only works with delegates and interfaces. It's not a modifier that I could take and apply to my SQL repository. Only interfaces. So let's try to make iRepository of T covariant. And now I do a build, and I get some new compiler errors. And the reason is covariance is only supported when you have methods returning the covariant type parameter. It's dangerous and illegal as far as the C# compiler is concerned to make an interface covariant when methods take parameters of type T. And if you think very deeply about this, it makes sense. Imagine I have an iRepository of employee, and I pass it to someone who treats it as an iRepository of person. It would be okay to read objects from that repository because all the objects it returns are employees, which derive from person, so that's never going to cause a problem. But it would be bad to give that repository a person as a parameter because the repository might try to interact with it or save it or use some characteristic of an employee when the object it got was really only a person. That's a bit of a problem. So can I make iRepository of T covariant? The short answer is no, But let's see if we can work around this problem so that we can share dump people with both employee and person objects. What I can do is define another interface. I will create an interface read-only repository of T, where T is going to be covariant. And I'll have this implement or inherit disposable. And now what I can do with this interface definition is pick out just the methods that return items of type T or iQueryable of T and put those in my iReadOnly repository. And now iRepository is not going to be covariant, but iReadOnly repository is going to be covariant. And I can say that an iRepository of T is also a read-only repository of T, which is really saying that it provides all the read operations too. And now Control-K, Control-D to do some formatting, have things line up. And let's go back into the program. Although I cannot have an iRepository of person here, I'm hoping I can have an iRead-only repository of person here. And now I can do a build, and the C# compiler is happy to make that conversion. And if I run the program, it does tell me there's 2 employees. It finds the employee with an ID of 1, and then it dumps both the employees out of the database, or both the person objects that it finds from the repository. And that's the common scenario for needing covariance, which I should note is only available for interfaces like this starting with C# 4. So this wasn't possible in version 3 or previous versions of C#. But the common scenario here is that I want to reuse some logic and work with base types as much as possible. And covariance helps to enable that because I can treat IEnumerable or iRead-only repository of employee as an IEnumerable or iRead-only repository of person. And that allows me to share the logic between both people objects and employee objects. That's covariance. Let's look at contravariance next.